Now we are going to solve equations with radicals. What do equations have that expressions don't? Right, an equal sign. And so when we solve our radical equations, the first thing we're going to do is isolate whatever the radical is. Then if it's a square root, we'll square both sides. If it's a cube root, what will we do to both sides? Right, we'll cube both sides, and then we'll solve from there. So you've got a lot of math intuition about these problems without ever having seen them before. Like in number 1, I bet you would know what to do. What would I do first in number 1? Right, subtract 1 from both sides, right? Subtract 1 from both sides. So when I subtract 1, 2 root 3x plus 4 equals 14. What do you think comes next? Right, divide by 2, so square root of 3x plus 14, or plus 4 rather, equals 7. And then what am I going to do to both sides to get rid of the square root? Right, you're going to square both sides. So I square both sides. Square both sides, come on. Square both sides, doesn't want me to do it, there we go. So then I get 3x plus 4 equals 49, so 3x is 45, so x is 15, right? Good. What about number 2? Number 2 is a little bit different. I agree that you have to subtract 8 from both sides, but then something's weird, right? How can the square root equal a negative? It actually can't, and so you can tell right then and there that this is an empty set problem. Done. Now some people will say, oh, what, can't you just square both sides? You can. So if I square both sides, x plus 1 equals 36, x equals 35, you might be like, oh, it's 35. But if you plug it back in, it doesn't work. You could try it if you want, but it doesn't work. So as long as you see that square root equal negative, you're good to say just empty set. Here, I square both sides here, and I get 8x equals x. Some people get scared there. You could just subtract x from both sides and divide by 7. X is 0. Now you might think that number 4 is empty set. Is number 4 empty set? Can a cube root equal a negative? A cube root actually can equal a negative, so you are okay on that one to cube both sides and then solve as normal. X equals negative 63. So those have all been kind of simpler. When we get to number 5, now we're in the big leagues here because we have 2 square roots. What you cannot do is square everything. I'll say it again. What you cannot do is square everything. Let me just show you for a second. Do you agree that 1 plus 2 equals 3? Yes. Does that mean that 1 squared plus 2 squared equals 3 squared? No. You cannot square everything in an equation. So you cannot, don't even write that down, you cannot do that. Not. So how do you do it? So what we're going to do is isolate our radicals, like we said in our directions, isolate them one at a time. Now from here we can square both sides, but now on the right we're squaring that quantity. And what do we use to square a quantity like that? Rhymes with boil. Right, FOIL. Now I'm a good FOILer, so I FOILed that in my head. If you prefer, you can write it out 2 times. That's totally fine. And then now I'm going to see some fun stuff like those m's canceling on both sides, making my life easier. I subtract 4 from both sides, divide both sides by 4, so I get square root of m equals 2, and now I square both sides again, and I get m equals 4. And you really should always plug in your answers and make sure that works. That one does work. But you have to be careful because sometimes we get extraneous values with here, these problems that don't work. I don't know if I have one in the notes, but I know there's one on the homework. Here I can square both sides. Again, on the right-hand side, I'm squaring that entire quantity. So this is a FOIL question. I'm foiling it in my head. 1 plus 2 root 2a minus 3 plus 2a minus 3. Now we're not going to be as lucky here. We're going to get a quadratic. So if I subtract 2a from both sides, I get a minus 2 equals 2 root 2a minus 3 minus 2. So those negative 2's will cancel out. Now here, I'm going to do something a little bit different. I'm going to square both sides here. I could divide both sides by 2, but then I'd get a fraction, and that's just going to be annoying. So this is going to be 4 times the quantity 2a minus 3, or a squared equals 8a minus 12. So now I have a quadratic, which I'm moving all to one side, a minus 6, a minus 2, a equals 6, and a equals 2. Whenever you get two answers, you really do want to check them. So I'm just doing like a quick check in my head right here that the 6 works, and then if I take that, square root of 4 is 2, and this one works too. So that one happens to both work, but I know that there's at least one on the homework, and I think even one on the test where one of the answers doesn't work. Okay, down to the last 2. These are a little bit different. They're not your typical questions, but they're going to plant some seeds for some things we're going to do later in the year, so we keep them in here. This takes us back to rational exponents, x to the 2/3 power. I could write it as a radical. So what we're going to do is raise both sides to the reciprocal power. Raise both sides to the reciprocal power. Why would we do that? What happens when we raise a power to a power? What do we do with the exponents? Right, we multiply them. And so 2/3 times 3/2, that's just 1, or x to the first, or x. 16 to the 3/2 is the square root of 16 cubed. So x is equal to 4 cubed, or 64. Which you might even be able to figure that one out in your head. But later in the year, we're going to do some more work with that raising to the reciprocal power. So we just plant the seed. Also later in the year, we're going to do some problems like this. This is not technically a radical equation because the x is not under square root. But it's going to use something, I'll give you a hint, it rhymes with tractor. Yes, factor. How can I factor? Well, I'm going to factor out the x. 2 minus root 3 equals 7. And I'm going to divide both sides by 2 minus root 3. And then, can I leave it like that? Unfortunately, I cannot. What do I have to multiply top and bottom by? Do you remember? Conjugate, kind of like the opposite, 2 plus root 3. So now I'm going to get 7 times 2 plus root 3. I save that in case it cancels. When I FOIL this, first, outers and inners cancel. Minus 3 is just 1. So I can leave my answer like that, or I can distribute the 7, kind of either way. So it's not a typical radical equation, but planting that factor seed is going to be important for us later. Similarly, the both sides reciprocal is going to be useful later. So this is solving equations with radicals.